Good day, everybody. Today we are going to be working with the quadratic formula. Now, the quadratic formula is always a lifesaver when it comes to finding the values of x within a a quadratic equation. So first things first, we are going to derive this formula using completing the square, and then afterwards we are going to try and solve for x after we completed the square. And then after we derive this formula, we will find application questions where we will use the quadratic formula. In cases where you don't feel like doing grouping or you are not able to use grouping method when we have coefficients in front of the x square. Let's get straight into this. Okay, so from here we have the standard quadratic equation, right, in general form. So through this thing, I am going to just give you the steps, okay? You need to follow it and you need to understand them, but I'm going to try and do it slowly, not too fast, right? So first things first, when we're completing the square, we need to take the constant over. So therefore we are left with ax squared plus bx equals to negative c, in this case over here, from positive c to negative c. The next step we are going to do is remove this coefficient, because we don't like the coefficient. So we're going to divide both sides by a. So divide this by a, and then we're going to take this thing and divide it by a. And what are we left with? Well, clearly, when we divide both sides by a, the a's will cancel here, and we are left with x squared, right? It's just going to be x squared, but I'm going to write the whole thing down. Ax squared divided by a plus bx divided by a equals to negative c over a. And then notice the a's cancel. And then this implies to us we have x squared plus bx over a is equal to negative c over a. Now here's the funny part, right? This is the part where students will probably get lost. Notice from completing the square, when we have x squared plus bx over a, we need to add both sides by b over 2a. So add both sides by b over 2a to the power of 2. And then on this side it will be minus c over a plus b over 2a raised to the power of 2. In this case over here, the reason why we do it is because we want to use the knowledge of an addition of two perfect squares to give us an output over here, right, such that what we're going to have is x plus b over 2a raised to the power of 2. Okay, so I know this 2 is here, but at the same time, when you think about it, from the standard form, you would usually have like 2ab, but the 2 will somehow cancel. Okay, and we have a square. And this is going to be equal to the same thing. So negative c over a plus b over 2a raised to the power of 2. But one thing that I actually want to do here, right, is I want to actually use exponent laws here, where we have the square that can go into the numerator and the denominator. And what we're going to have? We're going to have b squared over 2a squared all together is just going to be 4a squared. Okay, so hopefully that makes everything better. Alright, and then what's next? We need to recall from lowest common denominators on the right hand side, so we can write this in a full fraction. So what we do at the bottom, we do at the top. Remember, this is the highest fraction that we have, or sorry, the most that we can get from the denominator is 4a squared, and this one we just have a. So in order to get to 4a squared, we just need to multiply by 4a again. If we multiply the bottom and the top by 4a, we get 4a squared on the denominator for the first term. Therefore, we'll have negative c multiplied by 4a, all divided by 4a squared, plus b squared divided by 4a squared. And then notice that this side is x plus b over 2a raised to the power of 2. Okay. So x plus b b over 2a raised to the power of 2 is just going to be the same as, notice we have the same denominator, so we'll write it as the same fraction now. So it'll be, if we simplify this numerator, we're just going to have negative 4ac divided by, oh sorry, let's do the plus first. It'll be plus b squared divided by 4ac, sorry, 4a squared. Okay. And then from here, what we can do is solve for x. Okay. So to solve for x, we need to take the square root on both sides. When we take the square root on both sides, we're going to be left with x plus b over 2a, which is equal to the square root, and don't forget about the plus minus, by the way, when we take the square root on both sides, plus minus the square root of, let me just rewrite this numerator as b squared minus 4ac, because it's better to write the positives first, all divided by 4a squared. Okay. And then from here, we can clearly just take the b over 2a to the other side. So then what are we left with? X is equal to negative b divided by 2a plus minus, and we need to know our square root properties that say the square root of x over y is the same as the square root of x over the square root of y. So therefore, we can write it as plus minus the square root of b squared minus 4ac, okay, all divided by the square root of 4a squared is just 2a. Okay, and then notice we have a common denominator between a plus or a minus sign, so therefore this implies to us that x is equal to, and I'm going to zoom in for this one so it's like clearer, x is going to be equal to negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Okay, so therefore we have gotten our quadratic formula. Now that we've actually derived the quadratic formula from all of these steps, and it's not that much steps, we are going to apply this quadratic formula to different quadratic equations to get our x values, which we call our roots of an equation. You'll learn this also more in the functions. It's an all of this isn't just in like all of this is just applied in functions. So let's get into the first example. Alright, so this first example I will do for you, and then the next example I'm going to give to you to practice. Okay. So in this case, we are going to be using the quadratic formula to solve for x. Okay. So what do we notice? The standard form for a quadratic equation is ax squared minus bx plus c equals to 0. And in this case here, 2 is the same. Let me rather do it in a different color. 2 is the same as a. Here, negative 5 is the same as, is this minus? I meant plus. Just the negative 5 is the same as the positive b, as the b value, and the negative 8 is the same as the c value. So therefore, what we notice is that a is equal to 2, b is equal to negative 5, and c is equal to negative 8. Alright, so that is what we're going to plug into our equation. So therefore, for this one over here, x is just going to be equal to, and I'm going to write this a little bit bigger here, so negative b, what is b equal to? It's just negative 5. Okay, plus minus the square root of b squared, which is just going to be negative 5 all squared minus 4 into a. What is a? It's 2. And then we multiply it by c, which is going to be negative 8. Okay. That is what we have for the top. Now for the bottom, it's going to be 2 times a, so 2a. And what is a equal to? A is just equal to 2. So now notice that this is broken up into a point where you can say plus. This is where the expression is, where you can say first plus all of this stuff, and then you'll say minus for the next x value. So when we are working with the plus version, our x value is going to be equal to what? And when we are working with the negative version, what is our x value going to be for that one? So let's use a calculator for this. So the first one, with the positive, we are going to get 5 plus the square root of 89, all divided by 4. And this, if you check out the approximation, is approximately going to be 3.608. Okay. And then what about if we say a negative? So all we do is just go all the way to the positive sign, change it to a negative sign on the calculator, and therefore what do we have? 5 minus the square root of 89 over 4, which is actually approximately equal to, approximately negative 1.104. 108. And there's our roots of our equation, if you want to look at it in that way as well. And something I'm going to give you as a hint is that when we have an equation or a function which is equal to 0, what does that imply? It implies to us that y is equal to 0. And when is y equal to 0, what are we trying to find? This implies that we are trying to find the x-intercepts. So therefore, the application, I know I don't have to say this, but I'm going to say it anyway. The application of letting a trinomial be equal to 0 is the same as saying a function being equal to 0 when you say y is equal to 0 to find the x-intercepts. So what did we just find? We found the roots of the function, which are the x-intercepts. So when we go into the nature of roots and everything, you'll now at least have a better understanding of what you're trying to find. So this is the question that I want you guys to do on your own. Okay, so here's your question that I want you to try on your own. Okay, so the question is going to be, solve for x if 12 plus 8x minus 2x squared is equal to 0. So use the quadratic formula for this one. It's a little bit of a tricky one here because I'm not going to give you the reason why. I want you to figure that one out. So that would be the quadratic equation.